So I will share my screen. Okay, today we can go with Minikube, right?
Yes.
Okay. So anyone know what is Minikube? Any idea?
Minikube is a tool that you can use to practice Kubernetes on a single machine. So it simulates the network and all of the cluster management uh, capabilities of Kubernetes, but it runs on your single local machine. So it's
Right.
mainly for training, I think, and testing, maybe.
Yes. So Minikube. Minikube, it's a lightweight, okay. Okay. It's a lightweight tool. It's a lightweight tool to run Kubernetes locally on our machine. Coming to Minikube, we can run the Kubernetes in a single machine, okay? Single node machine. Single node machine. Single node Kubernetes cluster. Okay. Locally. Virtual machine or laptop, anywhere we can run it on that. So this is mainly, or it's mainly used for learning, then development and testing of application. Testing of Kubernetes application. Got it. So basically it's a lightweight tool, okay? Minikube is a lightweight tool that allows run a single node Kubernetes cluster locally. So before we install Kubernetes, it's not a single node, right? There is a master node, worker node like that. But coming to Minikube, it's a single node and it's used for learning purpose and development purpose, and we can test the application as well. Got it.
So when coming to Minikube, there is no concept of master and worker nodes. It's
No, no, no. We will get after setting Kubernetes using Minikube, we will get a Kubernetes environment. So just we can try similar like Kube, we can run kubectl and we can run application like that.
okay.
That Minikube gives a Kubernetes environment. This is good for learning Kubernetes. So we don't go with any other self-hosted or managed one. So I'm going to launch a main instance, okay, to run Minikube. For coming to Minikube, it's running on a single node machine, right? But we need to ensure that that machine has enough CPU and memory. I think 2 GB is the mandatory. 2 GB RAM and 2 GB, 1 GB core. 2 GB RAM is mandatory, yes. Otherwise, whenever we installing the tool, we will there is a error. So I will show you. Okay, first we can go with the base machine and we can try. So we can check. I will go with the T2 micro. Okay, T2 micro. See how much one versus CPU and 1 GB RAM. Rest of them seems fine. We can launch mission. Okay. So we launch instance and update the package manager. So coming to Minikube, okay, that Minikube need a container runtime. Okay. So in this case, we using Docker and we need to define the Docker as the container driver for Minikube. So first I'm going to install Docker. It install Docker. So Docker is installed. Then we need to install the dependencies, right? The dependencies like kubectl. So we need to call that package from the official path. See the storage API Kubernetes release. Also, it's moving from C executor permission and moving from root to user local bin kubectl. Then we need to download the package for Minikube. Okay. So this is a command to call that Minikube from the directory. You can see the URL, right? HTTPS storage. And here you can see the second command. There's ampersand, 2 ampersand you can see. After 2 ampersand, after the ampersand change modification to the executable file of Minikube, then we need to move the Minikube to user bin block, user bin. It's completed. We need to install one more tool here, okay? That is called a contract apt install. That is for networking, okay? Creating a networking within the Minikube system. So this is the command to install contract. Now we can directly start the Minikube tool, okay? Using Minikube tool command. So this is a command Minikube start. Then we need to define the driver, okay? Here we define the driver as Docker. So this after this command, I mean, when I hit enter, the Minikube will start with the driver Docker. Yes, this is error. Exited due to RSRC insufficient core. Docker has less than 2 core CPU, but Kubernetes require at least 2 available. So coming to our case, we use T2 micro, right? So C2 micro has only 1 core CPU. So what will we
You might
do?
upgrade the machine probably.
Right. So we need to vertically scaling this machine. So first to go to the dashboard and stop the machine. Now we will manually scale up this machine. Vertical scaling. This is called vertical scaling. Go to instance settings. Here we can see change instance type. See, click on that. And here you can see no instance type. We need to define here. Okay. Select there. And now we need to change to T2 micro to T2 medium. And here we can get the core. This is the difference, okay, for the T2 micro and T2. So change. See now, it's changed to T2 medium. Now we need to start that machine. Okay, machine is successfully login. So okay, we can check the CPU as well, LS CPU. For 2. That's fine. Now we need to run that command again, okay? Minikube start driver Docker. So now it's starting the tool. Exit due to DRV root. Docker driver should not use in root privilege. Okay. So we need to add manually. So I'm creating a user, okay, and change that permission. So adding that Docker to the new group Docker so that the above error will remove. Okay, driver should not use with the root privilege. Above we use with the root privilege. Also, we need to switch to user from root to the user. Okay, so exit. Now you can see we are on root. Okay, so now we are in Ubuntu. Now we need to run the same command. We got no error. Permission denied trying to Docker daemon. Docker status. Docker. Okay. Docker is up and running, but this is due to the permission, okay? Okay, now it started. So now Minikube will bootstrapping Kubernetes with a single node, okay? So you can see the logs as well. Starting Minikube primary control point node in Minikube cluster. Also, we can see it will taking Kubernetes version latest one, right? 1.32. See, we got this message, okay? Done. kubectl is now configured to use Minikube cluster and default namespace by default. So now we can run kubectl command. Kubectl get node. See, Minikube ready, control plane. Kubectl get pod. No space and default namespace. Yeah, everything seems good. Create namespace. Name test. So everything is working fine, right? See. Also, we can deploy some sample application as well, okay? So imperative way, I'm going to run this to-do list application, okay? It will take that image from Cube code, React to-do list application, hit enter. So application created, kubectl, get pod, see, container creation, SVC. See, application is up and running. Now we need to expose the same application, okay, using its application, creating a service, okay. First creating, so this is imperative way to expose the application using service. So kubectl expose port, then the port name. This is a port name, and we need to define the type. This is imperative way, okay, not that declarative way. For declarative, we need to write up the YAML file, right, and define that type. That is not port, the port number, and the name of the application to-do list service. So this will create a service, the name with the to-do list service. Now we can check the service. See, Got it, all of you. So this is the port number, okay? Sorry. This is how that specific application access with inside Kubernetes cluster. So this is the IP address for the cluster port, and this is the application static port, okay? Port number. So this is only accessible internally because our cluster IP 192. So we need to expose this application outside. That's his next scenario because coming to Minikube, we need to take that application from the cluster to our own machine. Okay, so there is a command we use that is called port forwarding. So using port forwarding, we forward that container port to our host machine port. Okay, so there's a command that came with the kubectl command. Okay, that kubectl port forward, that's a native command. Then we need to define the service name. So svc / then service name. Define the service name here. And the port number that we are going to map. This is the local machine port number. And the container port number that we need to define. This one. And the address who can, that is 000, all can access that application. Now it's port forwarded, that specific application. Now we need to open the port number 3000 and access the application. I put it on the chat. Can anyone try to access 3000? It's accessible, right? Of you. There's a space, I think, after the IP, there's a space there. So remove the space as well. Yeah, you can able to access that to-do list application. It's accessible, right? All of you.
So I can access. I didn't get the part of service forwarding, some port forwarding. Why can't you use?
Port forwarding means taking that application from that port. In real world scenario, I will draw the diagram. This is a port, right? This is a container. Okay. So this
Can't
is
we
service.
access that with the URL which is given there?
This one, right?
30251. Yeah.
This is inside the cluster. Okay, inside the cluster. This is the port number to access the application. So this is service actually. The 80 is the service that is sitting. For example, this is our application container. Okay, this is container. So coming to the container port 30 30251. This is a port number that application expose. Got it. So this is binding with the port number 80 of the service. That's listed here. All these things work inside the cluster. Got it. That means there is a service. So this is application to-do list, and there is a service. And the service port number. Here there is a binding, okay, the 80 and 3025 binding there. So service is we using HTTP, right? HTTP. So that's why here the port number that protocol using 80 here. So that access directly hitting to the specific service. So that service taking the all HTTP request, then mapping to the container port. So here we have one application that expose application via port number 3030251, right? So it routing to the specific application. Okay. Now, this is a working principle within the container or within the Kubernetes infrastructure. Now we need to take that application outside the Kubernetes cluster. So that we need to use port forward. And we need to define the service. And we need to define the port that we are going to use. So first port should be host machine port. And second one, the service that we using, that is 80. So one request, okay, if anyone remote person using that, but that private machine IP with the port number 3000, okay. So the 3000 is mapping with the port number 80 with the service actually. This is a unique thing, okay. That is binding with the specific service. So the request came to the specific service, and then it moved to the request to the container port 3025. Because the 80, again, you can see about the 80 is mapped with the container port. For example, if say one more application here, okay. So that application using same thing, okay, 80 and 30001. Coming to node port, we using port number from 3000, 30,000 to 32,000 something like. So in between, we need to choose any port here. So console like that second application using this port number. So how we will do that? Same way, kubectl port forward, define the service name for the same, this one. Then using that port number, okay, here we can't use 3000 because 3000 using for this one. So we can use 3001, then same 80. That's only taking the request and move to the specific service that we define. So in this case, the service name is different, right? So that's why it's working.
Yesterday, like if it is a cluster IP, it is within the cluster, like Kubernetes. We have like change it to node port, and then we are able to access this outside, right?
Yes, that's why, because yesterday we taken two machine, right? And for the this is our worker node and this is a master node, right? So coming to the worker node, we directly deploy the application. I mean, not directly via master, it deploy the application to the worker node, right? So we know that EC mission IP. So directly we can access. In this case, we can't access because that specific port running on the infrastructure only. Okay, we don't know which node or there is no. It's running on single node, right? Minikube.
Yeah, no
So
idea.
that's why, yeah, we need to use the port forwarding.
Can you command as Minikube IP?
Okay. Come again.
Minikube IP?
Minikube ID or
IP.
I didn't get you actually.
Can you type Minikube space IP?
Oh, okay.
Okay. You said like 192, 168. Is it, this is related to something? What is that? Is it a private IP or?
Private.
Okay.
Because we use one networking service installed, right? Contract. So
Okay.
contract used to track network connections and uh, networking things will be handled by the contract. So it will assigning IP and all
Okay.
contract. Yeah, establish. So here we can see that network things related to contract.
Taufik, did you cover horizontal or vertical or like scaling?
Vertical.
No, did you cover it? Like today we have shown like manual stuff, how to do vertical one.
Manual
How about
scaling, vertical. So how we will do the vertical means we only added the resources coming to vertical, adding machine or VM resource count. That means the machine 2 GB RAM and 2 GB CPU. Sorry, 2 core CPU. So we need to scale up using vertical. Then what we'll do, we need to stop the machine and selecting more configuration like uh, that category or family we can change T2 medium to T2 large like that and restart the machine. So that's scenario. But this is not good for production
because
because we need to stop that machine.
yeah, downtime.
Yeah, business impact there. So for that, we need to go with the horizontal scaling. So horizontal scaling, how we will spin up the machine identical. For example, we have a UC2 machine, VM. Some applications there, okay, application dependencies, everything is there. The application is live. So we got more request. So based on the request, that CPU and memory going high. So we need to scale up the machine, right? In this case, scenario, we need to go with the horizontal scaling. So what will happen? It will automatically create a similar type mission, okay, identical mission creating with the same configuration. Even the application dependency, everything will be same. So we don't bother about the second mission, but the second mission will be there and route the traffic to the second mission as well. I mean the incoming traffic, so that those two missions can balance the application load as well, the incoming traffic. So there is a auto scaling method there in AWS auto scaling. So there we can configure everything, how to scaling based on the requirement, okay, the CPU requirement or memory. If it is going to above 50% or 60 whatever, so it will automatically the scaling automatically deploy another machine
I think
using horizontal.
you have covered this. Yeah.
Yes, yes. But for horizontal scaling, we have one section, okay? So how to automatically, spin up machines. But similar way, we do the same in Kubernetes, horizontal pod autoscaler. Remember that one. So you in scaling pods. So this is the way we can see the live logs of our application. See, now I am accessing the application. That is, this logs belongs. Anyone can access, so we will get the details. Someone use Mac OS, right?
Mine is Windows.
Okay. This is my log actually. I'm Windows and NT. Whenever we using Datadog class, go with the Datadog class, I will show you more detail about that live logs. 309.
Yeah, hi Tawfiq, Mahesh here.
Hi, Mahesh.
Hi. What is the difference between AWS Cloud and OpenShift Cloud?
Sorry?
What is the difference in AWS and OpenShift?
AWS and OpenShift, right?
Yeah.
OpenShift is container platform, right? Similar like Kubernetes.
Okay. So,
So, for example, if we deploy application, okay, so we need to similar like the Kubernetes, we can go with it's alternative actually. OpenShift is alternative one.
alternative of AWS.
No. It's separate, not related to AWS.
Okay. Okay. How
For
are we going
AWS,
to on?
EKS native one is EKS.
Okay. Okay. Yes. How are you going to onboard the cloud environments to OpenShift?
Cloud environment
About
means
uh, uh, there are infrastructure already exist in a different environment where we have to onboard to the OpenShift. For example, it is already in Azure or some IBM cloud that needs to be onboarded to the different.
you mean application migration, right?
Correct.
Okay. So there is a migration process we need to follow, I think.
Mm.
So before that, we need to study the application, where the application currently running, and dependencies, everything we need to check. And gradually move to, for example, for example, we have an application running in a EC2 machine. So the requirement is we need to onboard the same application to Kubernetes, right?
Yes.
Similar way, in your case, we need to onboard that application to OpenShift, right?
OpenShift or Azure?
Azure. I mean, Azure is a cloud platform, right?
Correct. It's a different cloud platform, like AWS. Correct.
And this is a container platform actually, similar like Kubernetes, container orchestrator. Both are same.
Okay. The question from interviewer is onboarding to cloud environments like OpenShift or Azure, etc.
That is for a specific application, I think, right?
Yes. Some banking application.
Okay. I think he, for example, there is some banking application there. So we need to deploy the application to any cloud infra or any container application. That's, I think, he means.
Okay. They've clearly mentioned that OpenShift or Azure. That means we have to work on that Azure, right? Azure part also. I mean, I have to go through the Azure part also.
Okay.
Thank you.
Yeah.
Maybe he mean using OpenShift, they have to go to Azure. Migrate that one to Azure.
OpenShift to Azure, right?
Using just like Kubernetes, how we use Kubernetes like to container orchestration, OpenShift is also the similar way, right? A container orchestrator. So using this in combination to Azure, we have to move that banking to Azure. OpenShift container orchestration along with Azure. This banking application should go into Azure.
Got it.
Correct.
OpenShift we can deploy in two way coming to Azure. There is a ARO there, Azure Red Hat OpenShift. That is fully managed by Microsoft and Red Hat.
Okay.
Azure ARO. Or else we can go with the self-hosted ones. This is the one.
What is self-hosted in Azure?
Sorry?
Which one is the self-hosted in Azure? Like in AWS, it's a EKS.
Yeah, self-hosted means manually we need to set up this one, like OpenShift.
Correct.
Like taking some virtual machine and install OpenShift manually on Azure.
Okay.
For native Kubernetes, Azure have Kubernetes also. That is AKS, Azure Kubernetes Service.
Azure Kubernetes Service, AKS.
AKS.
Okay. I got it.
For AWS, EKS.
EKS.
Elastic
Yeah, got it. Yeah.
Managed one.
Yeah, I know.
So anyone have any doubt regarding Minikube? Can you do it on your environment if I share that resource?
It would be great actually. I need the like whatever the commands you have used. If
Yeah,
you
I will
can
share
share
it.
that. And also the previous videos, please, Taufik.
Yeah, I will upload today.
Thank you.
Then we can wind up, right? All of you.
I'm good.
Sure. Good morning, Tofik sir. Good night, everybody over here. Thank you for class.
Good night. Good night, all.
Thank you.